Good whatever time of the day it is when you're watching this. I thought I would make a quick video on how to use Emacs for Agda in particular, since this is spread out in the other videos and it could be a bit hard to find. So I'm going to start Emacs and open an Agda file which I prepared a little bit. So I start it and I see that everything is okay because I have an Agda menu. Okay, so the first command that could be good to know about is how to save the file. And I do that with Control X, Control S for save. And now it says no changes need to be saved because I haven't changed anything yet. Okay, so the second most important command for using Emacs to do Agda is to load the file, which you could always do all of these things by looking in the menu, but that gets a bit repetitive, so it makes sense to learn the keyboard shortcuts, which you will do anyway if you actually play with this. So we see here that to load it, we do Control C, Control L. So let's do that, Control C, Control L. It takes a little while, and now it all turns into color. And these things that used to be question marks, I'm going to deactivate this. They used to look like this. I have changed the question marks into something equivalent. So they used to look like this, and when we load the file, the question mark turns into these green numbered things. So these are called goals or sheds or holes, all meaning the same thing. And you can see a list of them down here in the all goals buffer. Right. So you see that the first one, numbered 0, is something of this type, and the second one and the third one have these two types, so type A. So that tells us what we have to fill in order to complete our program. Okay, so that's how we load a file, and now to actually start writing our program, we have to fill in these holes, right? And the way we typically do this is we write something, and then we give it, which is something you do. You can right click on the hole if you want, and you see what you can do, and give is one of the things you can do. So what we typically do is we don't give the whole thing at once because our brains are too small. Instead, we think step by step. So here, for example, I can see that my goal is to give something of a product type. So I know that this is going to be something, comma, something. Something in the first component, something in the second component. And I put question marks where I don't know what to put in yet. So there's two question marks because it's going to be something in the first component and something in the second component. And then I give that Control C, Control space, and my goal has turned from one goal into two sub-goals that I know how to fill in. Right. And I can look at these sub-goals and I can see what I have and what I have to do by doing Control C, Control comma. And then down here in this buffer, I get the goal I have and I get the context of what I have. So I see that I have an A, which is a set, which is not in scope because it's been introduced implicitly here. And I have a little a of type big A. Okay, and I have to produce something of type A. So probably I want to give this little a here, right? So the way to do that is to type A in the hole and then do Control C, Control space to give it. But if I go back, so I just make that a hole again by making it a question mark, I reload the file. I could also do another thing. So if I type the A in the goal and then I do, instead of Control C, Control comma, which showed me the goal and my context, I can also do Control C, Control full stop, which shows me the same information, but it also shows me the type of the thing I have typed in the hole already. So here A. So that's a good way to see if what you think is the right thing matches before you give it, and just to see if you're on the right track. Okay, so I'm going to give that Control C, Control space, and then I'm going to move to the next goal, and I do see what I have to do, Control C, Control space, comma, sorry. Okay, so now my goal is this A, arrow, A, arrow, A. And here's another thing you can do. If something has an obvious way to make progress, then you can do Control C, Control R for refine. And Agda will try to make the obvious thing. So in this case, if I go back, we had to introduce something of function type, and the obvious way to introduce something of function type is to make a lambda abstraction over these two arguments. So Agda is going to do that for us. And often what we have to do is we have to then rename these things to something we like. So I don't particularly like x subscript 1, I'm going to change that to a y instead. Right. Okay, and then every time you rename something, you have to reload the file so that Agda also knows that you renamed it. Okay, so now I can look here in the goal, Control-C, Control-Comma. I say I have to produce an A, and I have lots of A's around. So I'm going to pick, say, the Y and return that. Control-C, Control-Space. Okay, and then I reload the file just in case. And I see that I now have these two goals to go still, but I filled in the first goal step by step. Okay, so let's see if we can do this one. So here, of course, I could just return my A, but I want to do it in a complicated way, so I will see if I can use throwaway in order to do this. So I do Control-C, Control full stop to see what the type of throwaway is, and I see that it's this. So I'm going to do this in a complicated way. I would like to use the second projection of this in order to produce a final A. And one good thing you can do if things become complicated is that you can put sub-expressions in a where clause. So I write where, and then I say t equals throwaway, and then I reload the file. And now if I look here, Control-C, Control full stop at the type of t, I see that it has this type. So if I now take the second projection of t, try sub 2 of t, and look at the type of that, Control-C, Control full stop, then I have this type here. So if I just give that two more things, question marks for now, because I don't know what I want to put in yet, then I can give that, and I see that I'm happy. So now I have to solve these two sub-goals, so I'm just going to put in A and A here. Okay, and for clarity, you could also give the types of the things you give in your where clauses. So here, T had type A to A to A, I believe, and Agda will tell us off. So it didn't because it was a product. It's A times this. Right. So that's a good way to make your program more readable, and also maybe you know the type but you don't know the implementation yet. So then you can say, okay, if only I had something of this type, I don't know what it is. So I'm just going to call it a question mark for now. Then I can continue with the main construction, and then I can fill in this later, for example. And note that I could refer to A here because I had explicitly introduced it here on the left. So things are in scope in the where clauses only if they are in scope on the left-hand side of the definition. Okay, so finally, I also wanted to show one very important feature of interacting with Agda for Emacs, and that's pattern matching. So here I have an X, and I can see what the type of X is. It's A times A. So typically when you have something here on the left, you want a pattern match on it, and you do that with Control-C, Control-C for case. And then Agda will do a pattern matching for you, and often you have to go back and change the names to something you like better. So it's hard for Agda to pick the right names for you. So I'm going to call this X, and I'm going to call this Y, because I like this names better. And then I reload. Okay, and if I see now, I see that I have X and Y of these two types. And one final useful thing is that sometimes it's so easy to find the right thing that even a machine can do it. And then you can do Control-C, Control-A for auto, and which means that Agda will go and search for something of the right type. So here Agda happened to pick the second one. And one final thing is that if you want to try something, then let's say that I would like to try what this bar function is actually doing. So I'm going to give myself an A that I can try it on, and then I'll say bar of A, and I do Control-C, Control-N for normalize, and down here Agda will then normalize this function, so we'll run this function on the given arguments, and we see that it looked like a complicated expression where we took the second projection of foo and we fed it a bunch of a's, but actually what we get back in the end is just the a. So this is a convoluted way to write the identity function. And a good way to try this is to try to normalize things like this, Control-C, Control-N, normalize. And one final piece of useful command is that sometimes things go wrong, and then a good first step is to try to turn it off and on again, which you do by Agda and then kill and restart Agda. And hopefully you won't learn this keyboard shortcut by hand. And that just means that Agda, all the highlighting turns off, the process is restarted, and you can try to reload the file again, which can sometimes be useful if you make Agda end up in a faulty state. Shouldn't happen, but might happen. Okay, I hope that was useful, and good luck.